sets of 4. I'll make low lane, low DC. Lowest lane started at 0. The lowest DC started at what? 4. So that's the value at that lowest lane. Then I cycle through. You cycle through all the x values, starting with what?
4.
The x values?
Oh.
What does it say? N x equals what?
1.
Equals 1. So we went to here and we said, if that is lower than our DC, make him the lowest DC in the lowest lane. So is 9 lower than 4?
No.
Is this 9 lower than our current DC of 4?
No.
Is the 1 lower than our DC of 4?
Yes.
It is. That's the new lowest DC. And wherever he was, 3, is the new lowest lane. Then we said robot lane equals lowest lane. So a robot went there. Bam. Robot's on the board. Now I said, for every y position, starting at 0 and counting up, so here's 0, I'm going to start here. Lowest lane equals what?
Now,
Line 44. Lowest lane equals what?
the robot lane
The robot lane. What's the lowest lane?
is 3.
3. Where's our robot lane?
3.
So this doesn't change. Lowest DC is what?
1. Or
The value at robot lane, 1 space ahead of us. This is 1 space ahead of us. So what's lowest DC right now? 9. And then it's going to run a for loop. That's where we want to check this 9 against any other option. In this case, the 1. So our lowest DC is 9. Our lowest lane is 3. What should we compare this 9 against? The only other available path is the 1. Is 1 lower than 9? That'll become our lowest DC. That'll become our lowest lane. And we'll move to it. We'll move to that lane as we move forward, because we always move forward. So right here, this says, if it's valid, right, this if statement is just making sure it's on the board at all. Right? That's how we knew not to check over here. It didn't exist. We grab the lane that we're standing on. We look ahead 1 space here. That became our lowest DC and our lowest lane. The for loop says robot lane plus x. And what does x start as? -1. X equals -1. Robot lane plus x will be the current lane minus 1. That'll be this position. Let's be big enough. Guys, how do you compare two numbers to find a lower number?
greater than or equal to
Correct? What are the two numbers we would compare to? One of them you should know.
robot lane.
Well, let's say lowest lane. Just to be safe. Because we already had to execute this multiple times. We want to make sure we're saying lowest lane plus that. Because lowest lane can change. Or, sorry. Oh my goodness, so you're absolutely right. I apologize. I just got schooled. Yes, if the value stored at robot lane plus x, and what y value? Guys, what y value should we check? Y plus 1. Y plus 1.
Y plus 1. Y.
Same with this part, what we said, look at our current lane, but 1 space ahead of our y. This says look at our current lane to the side, but still just 1 space ahead. So if the value stored at these x and y coordinates is less than our lowest DC, then do what?
If it is, then step.
Make that the new, and what else?
And position?
We need to get the new lowest DC and lowest lane first. This for loop has to finish before we know who was the winner. So in here, right, just like we have a bracket, if we made it the new robot lane immediately, we wouldn't even compare the third guy. You need to make sure you do all the comparisons first. So make this the new lowest DC. Lowest DC equals what? Someone tell me what I should type.
Robot lane?
How do I access a variable in my array, what should I start writing?
Lowest line equals.
Guys, when you want to access the array, you have to type the array. Because it says level of these coordinates, what do I have to write?
Level robot line.
You guys are scaring me right now. We've done arrays for a long time. Look on the screen. Look one statement above. What did I write?
Level the robot line.
Level. Because level is the name of my array, correct?
Yeah.
Guys, when you want to access the array, when you want to get a variable from the array, you call the array name, and then you say what position to check. So I say, I need a variable, I need one of the values in my level, and what position should I check for X?
Robot line minus
It's
1.
right here. If the value at level, robot length plus X, Y plus 1, was less than lowest CC, this value must be that newest CC, right?
Yeah.
So I can just copy this. It goes right here. Remember, the whole idea of level is just not having to have a variable for every row called level 1, level 2, level 3. I can put that in the bracket. So I don't have to make various individual custom variables. I just make one big guy called level, and I call his X and Y for him. Right? This is level. When I want to access a variable in level, I say level 1, 2, level 1, 6. I just type in the coordinates, and it will give me the value stored at that location. So I've set the lowest BC, what else should I set? Lowest lane.
I thought it.
Lane should equal it.
It's a different outside the for loop.
Everything I'm asking is already on the screen, and then another place
Lowest line will equal robot line.
plus
X.
plus X. Because we've been checking to the left and then to the right. If you'd like, and I do enjoy doing this, you could even say set the lowest lane first, and that way you don't have to write this twice, you can just say lowest lane. So, going to start at the first row. Going to say grab the position directly beneath the robot. That's going to be the first guy to do comparison. So compare it to the left. We'll find out if that position even exists. If it does, we'll compare them. They'll then add 2 to negative 1. Negative 1 plus 2 is what?
1 plus 2 is 0.
Negative 1 plus 2.
Negative 1
1.
is
So he'll check at his position minus 1, and then his position plus 1. That's how he'll compare to the left and the right.
2 plus 2.
And if that's the lowest lane, lowest CC set them. When this for loop is done, how many positions have you checked?
4, 3. This one. So far?
What does my for loop count up from? It starts counting at what?
0. Nope. 1.
Looking at the inner for loop, it starts counting at negative 1.
Negative 1.
This for loop could only run up to 2 times. Because I'm either comparing that outer number, right? I grab the default starting lowest number. I'll either compare him against something unavailable, so I'll only compare these two, right? X is standing here. He only has to make one comparison. Does everyone understand why he only has to make one comparison?
Because he can't go further.
What's that?
He can't go further to the
He can't go to the right, so it's just one comparison. When he stands in the middle, though,
he can make 3.
he can do 2 comparisons. 3 options, but only 2 comparisons. So compare X and, or these 2, 6 and 5, and then whichever was lower will get compared against the 4. That's why I do this little bracket. 1 comparison, 2 comparison, 3 numbers. Let's say, this example, he's standing here and he's comparing 6, 5, and 4. Now he always grabs what values to start comparing with first. The ones directly below him. go compare this 5 over to the left, then the winner of that is whoever's on the right. So in the first bracket, the
5 would
5 or
win.
6 win.
5 would win.
5 would win. And 5 is compared to what?
4.
And who wins?
4.
So 2 comparisons, 3 numbers.
So the X minus 1 makes sure you only have 2 comparisons.
Correct. It goes from -1, and then it adds 2. Because I don't need to do 1. Or, sorry, I don't need to do 0. He was our starting guy. Robot lane plus 0 is robot lane. But robot lane plus -1 is a space to the left, and robot lane plus 1 is a space to the right. Lastly, when this for loop ends, we should have where you should go. So I could say robot lane equals what? What was the whole point of this for loop? What was I looking for? What was I looking for, you guys?
The lowest number of
The lowest number, because it was telling me which path to take. So my robot lane should be what? Lowest lane. I compared all the things to find out who's lower, but the position I'm going to move on to is lowest lane. And I'll print out here. I'll print out where the robot is. We're going to move to the lowest lane. I guess I should say robot lane, so I'm going to get it right here. Put a column between the values. Put the current Y value and 1. I'm going to run this. Actually, I'm going to add a cn.ignore. Oh, I forgot the other parentheses. I didn't need it, but I like my formatting. I like my text formatting. I think it looks pretty. All right. Those are all the positions he goes to. You started at 2, 0. Now what's happening in the right of the 2 numbers? There's an X and a Y coordinate. What's always happening towards Y coordinate?
it goes down.
Always increasing by 1, because he always has to move in the lane. And the left coordinate, of the X, he's figuring out which lane to take. So according to his out calculation, he started in lane 2, he stayed in lane 2 for 1, 2, 3, 4, 5 turns, then he jumped to lane 1, then to lane 0, which he stayed for a while, then back to 1, then to 2, then to 3, then to 2, then to 3, then to 2, then to 1, then to 0. Notice his X position, he never jumps more than 1 space, because he only ever checks below him, below to the left, and below to the right. If I increase this, I'll increase the number of lanes you can have to, let's say, actually I'll increase both of them. I'll say take a longer journey and have a wider choices. We'll give them 40 spaces and 12 lanes. Now because you can only move 1 lane at a time, it's very possible you won't go to all lanes. You still started in lane 2. You move to 1, then to 0, then to 1, then to 0, then to 1, then to 2, then to 3, then to 4, then to 5, then to 6. But you never went any higher than 6. Because you can only evaluate 3 choices at a time, a quarter of the board is all he's looking at once. If I have a board that's 12 lanes long and you can only have 3 spaces, we'll never compare more than 25% of the board. So it has to be pretty bizarre. There would have to be a very... All my lower numbers would have to go like in a diagonal path for him to go all the way over to the right. Or if he starts on the right, it'd be rare for him to go all the way to the left. These are assigned homework, so it sounds like this was a little confusing, huh?
A little bit.
Just a tad. Okay. I'm going to put this code in my Dropbox while I figure out what more we should do then. But we're following this for most of it, maybe, at least the first half.
Yeah.
started doing the checks, people were getting a little.
When the robot started moving and nothing like that.
Yeah.
Yeah.
All right. So copy the code in there, so you can look at it. You won't be. So you can take some time to check it and figure out why it works. Sounds like I want to do more stuff with you guys planning out your algorithms. And do some algorithm practice.
Also,
What's up?
with the code that we have, is there probably a way to attempt to add the difficulty level?
Difficulty level. Right now the computer plays it by himself. So if you wanted like a more difficult computer player, we can make him do a better evaluation, but currently you can't play against him, so it doesn't really do anything.